Welcome to the Math Record. Today we'll introduce the concept of vectors. This video will cover part 1 of chapter 9 in our Precalculus class. In this video, we will cover vector properties and learn how to graph vectors. So what is a vector? Well, a vector is basically represents the change in direction. So a vector. So imagine you have a regular point which is called xy, right? You use these curve like brackets. Let's say we had something like 2, 3, right? If you put this in a graph, it's at a point like this, right? So that's at 2, 3. Now we're gonna have something new, which is called a vector, which uses like these like triangle kind of ish brackets. So it's be triangle x, y. And if we write something like triangle 2, 3, I don't really know what's called. It's not a triangle. Basically, it's gonna be this is the change in x, and this is the change in y. So let's say you have 0.23, right? You have 0.23 right here. So that's 2, and this at 3. Then if you add the vector 2, 3, basically what it's gonna do is that it's gonna go to 2 to the right, and it's gonna go 3 up. X2 would be 2 represents the change in x, right? And 3 represents the change in y. So that's what the vectors are basically. It represents the change. It's not like a static number. It's gonna be like changing all the time. Sorry if that sounds like kind of dumb, but basically that's what vectors are. Now let's actually learn about like the general property of vectors. These are really basic and really self-explanatory. So let's say you have vectors u, v, and w, right? They usually follow like the arithmetic rules. So yeah, something like commutative, right? It states that you have vector u plus vector v is the same thing as vector v plus u. So basically, it's like this. Let's say you have vector u right here, and then vector v which goes up. It says the same thing as the vector v like this, which is the same thing as this, and then you have vector u. See how it's the same because it reached the same point. That's what it means. It has the same like it's the commutative property. This is the same kind of, and they kind of expand this further by putting the putting the associative property. So you now could add like a w. So u plus v plus w is the same thing as u plus v plus w. So the parentheses are different, but they're basically the same thing. So that's the associative property. Write this so it could be on one line. Okay. And then there is the zero property, which states like if you have vector u plus 0, then it's just the same thing as vector u. This is basically because it's 0, it just doesn't change anything. And then there's basically the one that I call is the identity. So you have the vector v plus the opposite of the vector, which is the negative v, is basically 0. Because if you have the vector v going this way, the opposite vector will go down this way. So when you add them together, it's kind of like 0. But if you just have vector negative v by itself, it's just going to go this way. But it has the same kind of like direction. You just kind of like flip it a little bit, across the origin. And then another important concept for these properties is basically scalars. Scalars. Which basically, let's say you have a vector v, right? Then you want to multiply it by like av, it turns to just av, basically. So let's give an example. Let's say you have something like v is equal to let's say v is equal to like 2, 3, right? Then 5v would be the same thing as 5 times 2, which is 10, and 5 times 3, which is 15. And that would be basically scalars. So like if you have like negative v, right, you just have negative 1 times 2, which is negative 2, and negative 1 times 3, which is negative 3. Or you have like 0v, which is basically just 2 times 0, which is 0, and then 3 times 0 is 0. So that's why it's like 0v is just 0. So that's basically scalars. It's kind of self-explanatory. Like a lot of these rules are really self-explanatory. If you think they're basic, then they probably are. So another way instead of writing it like at like 2, 3 for a vector, you write the vector as 2i plus 3j. So I would be representing the change in x, and j represents the change in y. So this would be like a new way to do this. So how would that work when you're like adding like basically numbers, right? So let's say we have u is equal to 3i plus 4j, and v is equal to 2i minus j, right? So we have something like 3, 4, right? Sorry, let me just, that's a line, 3, 4. I just want to show you this. You don't have to draw this line, you just have to draw the vector. So you have 3, 4, or that's u, or you have v, which is like 2 this way and then go down 1. So it's like this. So that's at 2, -1. So you have to draw this vector. So that's basically how you like graph those. Really self-explanatory, but just in case like you don't know, this is basically how you do it. It's gonna be a line. It's not gonna be a point. It's gonna be a line that because it represents the change in x and the change in y. So how would you like? What would you do if you want to add like these kind of like vectors? So you have u plus v, right? You add the vectors. You just add the x values together. So 3 plus 2 is 5. So you have 5i, and then 4 plus -1, which is just 3j. Or if you want to subtract them together, so u minus v. So it's just 3 minus 2, which is just I. So you just have 4 minus -1, which is 5j. So that's basically how you like work with adding and subtracting. We'll cover multiplying in like a different video because it's a little different and it's really strange. So, but that's the basic idea for adding and subtracting. Or you have scalars. So they always like put combinations. So you have 5u minus v. So then 5 times 3 is 15, right? And 15 minus 2 is 13. So you have 13i. And then 5 times 4 is 20. And 20 minus -1 is 21. So you have 21j. So you have 13i plus 21j. And that's what they usually use for vectors. Also in vectors, there's the concept of the magnitude. Sorry. This is basically like the same concept used in like polar and complex, which is just the distance from the origin. So so if you have like it looks like this, right? It moves 3 and then goes 4, so it's 3, 4, and you make the vector. You just want to find the length. So basically, you just use the Pythagorean theorem, because it makes a right triangle, kind of. So you make a 3 square plus a 4 square square root, and you get a 5. Same concept works for like v. So you have like 2 squared plus -1 squared. So that's 1 plus 4. That's equals like square root 5. You might just want to leave these as radicals. If you have like a number that's in a radical, just leave it as a radical. It's usually better to get it more precise than actually using decimals. Unless the question like asks you to like leave it in a leave it to like some kind of decimal, then you should probably just do that then. Just depending on what the question usually asks. I usually just leave it in a radical. So there's also the concept of position vectors. Alright, let me erase everything first. Concept of position vectors. This is like, let's say you have 2 points, right? We have 1, 1 and like 4, 3. Basically, if you're going to draw a line to it, you have 1, 1, right? And then you have 4, 3 right here, and you draw a line. A position vector is basically this line, but now it's going to be at the origin. It's going to start at the origin. That's what position vector is. So what you want to do is that, is the change in x and change in y. So 4 minus 3 is 3. 4 minus 1 is 3, right? And then 3 minus 1 is 2. So the vector is 3, 2, and it starts at 0. So it moves 3 and it moves 2 up. So it goes like this. 2. You don't have to draw this line. You can just draw this, basically. But, you sometimes want to specify, like, the magnitude, so it'll be, like, 3 squared plus 2 squared is, like, square root 13-ish. So that would be, like, how you write it, the vector with the magnitude. There's also another concept called the unit vector, which is basically, let's say you have a vector 3i plus 4j, right? But now you know this magnitude as 5 because we used that as a previous example. But now we want the magnitude to be 1. That's why it's called a unit vector. Unit, hence 1. So you want the vector, which is the same like shape as this, but just with magnitude 1. So how would that look? So we have like 3 plus 4j, which looks like this, right? But now we just want it like this, because this is magnitude 5 when you want magnitude 1. So basically what you do is, there's a really easy formula to do this. It's basically just v divided by the magnitude of v. The magnitude is represented by like two vertical lines, and then the vector, and then two more horizontal lines, two more vertical lines. So it's basically just 3i plus 4j, and then you put like the magnitude is 3 squared plus 4 squared, which is equal to 5. So it would just be 3 over 5j. 3 over 5i plus 4 over 5j, which makes sense because 3 over 5 squared plus 4 over 5 squared is just 1, and then square root of 1 is just 1, so the magnitude is just 1. But it's at the same direction because it moves 4 up, and it moves 3 to the right and then 4 up. Same with this, 3 to right, 4 up. Now it's just like a little different because now you're divided by 5. And that is basically the unit vector. Well, that basically covers everything for the introduction of vectors. Thanks for watching, and I'll see you at the next math record.